In the last lesson, we talked about how to write a ratio and how to solve a proportion and how those comparisons work. And you've been doing some problems on your own and together in class to figure those out and to learn them. But today we're going to apply that a little bit more to geometry. We started doing that a little bit at the end of the last lesson. And so I want you guys to be able to, at the end of this lesson, to recognize and define the conditions for similar polygons. Remember, at the very beginning of the school year, we talked about things that were congruent and how they were exactly the same. All of the measures were exactly the same. Similar polygons have a very strict set of definitions as well, right? You can't just say anything is congruent. Certain conditions have to be met. The same thing is true for polygons and when they're similar, okay? I want you to be able to find the value of a missing part of a polygon using something called a scale factor, whether that's, sometimes it'll be an angle, sometimes it'll be a side, sometimes it'll be a perimeter, sometimes it'll be area, okay, and we should be able to do that. And that's the last thing also, is to find this perimeter of a similar polygon given a scale factor. And so we'll talk about what the meaning of each of those words mean, and what we can do with each of them as we keep going through this lesson. So let's talk about similar polygons first. Similar polygons, okay? Similar polygons are polygons that have the same shape, but are not necessarily the same size, okay? Two polygons, though, are similar if and only if their corresponding angles are congruent and the corresponding lengths are proportional. So two polygons are similar if and only if their angles are congruent and their sides are proportional. So let me see if I can draw you some here. I can use hexagons. That's kind of fancy. Okay, so here's one hexagon, and here's another hexagon, and they're pretty close. Okay, and really the only difference between them is the size. And so when we're looking at these, all of the angles must be congruent, okay, for similar polygons. So this angle has to be congruent to this angle. And I want to make clear, when I say all angles have to be congruent, I don't mean that all of the angles in one figure have to be congruent. I mean all of the angles that correspond in the other figure are congruent to the one in the original figure. Okay, so this angle is congruent to that one. This angle is congruent to this one. Let's finish out that. This angle, congruent to this one. This angle, congruent to this one. I'm running out of colors. This angle is congruent to this one. And this angle is congruent to this one. All right? So it's a rainbow. I did not mean to do that. It kind of turned out that way. So those angles have to be congruent for two polygons to be similar. Okay, the angles just have to be. All right. Now, like congruent figures, similar polygons are named, okay, by their vertices, and they need to correspond correctly. So, for example, if I tell you that this has a name of A, B, C, D, E, and F, and I tell you that the other one has a name of L, M, N, O, P, I can't believe I just used P, or O, I mean, and Q, so it looks just like 0. Okay, I can say that polygon A, I got unplugged. I can tell you, though, that I can say that polygon A, B, C, D, E, and E, F. I don't know what the calibration is going to look like on this. Let's see what happens. A, B, C, D, E, F in that order. And this is the symbol for similar. Is similar to L, M, N, O, P, Q. It has to be in that order. I cannot say that polygon A, F, E, D, C, B is similar to L, M, N, O, P, Q. Okay? It's not true anymore. They must be in the same order. Okay? Angles have to be congruent. Corresponding vertices have to be listed that way. Okay, so now let's look at what we do with similar polygons when we're talking about length. Polygons are related, similar polygons are related by what we call a scale factor. Okay, a scale factor. And what a scale factor is, it basically controls the ratio of one side to another side for those two polygons. Okay, so let's use something with fewer sides than a hexagon because it gets hard to draw. So let's use two triangles here. Okay, move this one. Oh, I don't want to do that. All right. Okay, I have two triangles. I tell you that they're similar. I'm going to call them D, E, and F. And I'm going to call this other one P, Q, R. Okay, it looks like my calibration is just a little bit off. All right, so I'm going to tell you, okay, that triangle D, E, F is similar to triangle P, Q, R. So now you know that there exists a relationship. You know that angle D is congruent to angle P. You know that angle E is congruent to angle Q. You know that angle F is congruent to angle R. You also know that there are sides that are correspondent to each other, right? This side here is correspondent to this one, okay? This side here is correspondent to that one. I know that's a little bit sloppy. And then this side here, my calibration is definitely a little off now, is congruent to that one. Or not congruent, I'm sorry. Related to, correspondent to that one. So I may tell you that these two figures are related by a scale factor of 2, or for example, I can say that the scale factor from DEF to PQR is a scale factor, okay, of 2. Now when I say that, okay, let's say that I tell you that the scale factor of DEF to PQR is 2, okay? So that's how you'll see it. The scale factor of DEF to PQR is 2. So basically what I'm telling you is that their sides are related by a factor of 2. So if I tell you then that DE is 8, okay, what that means is it's related by a factor of 2. So to find PQ, I'm going to find this relationship as factor of 2. It's obviously smaller, so it's going to be 4. Okay, and let's say that the other leg is the same length. It'll also be 4. And then let's say that the bottom leg is 6. That would make it 3. You can also calculate scale factor. If I gave you a triangle and I told you the lengths of the sides and I told you that they were similar, you can actually calculate scale factor. So we can do that. Let's take 2 more triangles here. Okay. And let's say that I tell you that this one is XYZ and this one's ABC. And I tell you that triangle XYZ is similar to triangle ABC. And I want you to decide what the scale factor is. Well, you can't do it with no information, but you don't need much. Okay? If I tell you that triangle XYZ is similar to triangle ABC, and I tell you that XZ is 8, and that AC is 2, okay, then I can compare the two triangles and create a ratio where the sides are 8 to 2. Well, if the sides are 8 to 2, and remember I kind of like the fraction version better, and this is part of the reason why. If the sides are similar with a proportion of 8 to 2, then my scale factor is 4. Now, obviously, there is some common sense involved here, okay? When I go from the bigger triangle to the smaller triangle, I am looking at a scale factor of 4, meaning the bigger triangle is the one that's 4 times larger than the small one, right? So there is a measure of common sense here, okay? Similarly, I can switch them, and I can say that triangle ABC is similar to triangle XYZ. Okay, and using the same sides, I can calculate the scale factor going the other way with a ratio of 2 to 8, or 2 to 8, which means that the scale factor going the other way is just a 4th, right? So again, it does take a little bit of common sense to realize which way you're going. If you multiply by a fraction, obviously it's going to get smaller. If you multiply by something larger, a whole number, it's actually going to get bigger, okay? Finally, let's talk about perimeters. Perimeter is, of course, defined by the length of the measurement of the sides that go all the way around a polygon. So let's look at a couple of rectangles. Okay, I have a couple of rectangles here. Let's name them. I'm going to name them P, Q, R, S, and I'm going to name the other one A, B, C, D. Okay? If I tell you that P, Q, R, S is similar to A, B, C, D, if I tell you that this is true, okay, then the perimeter is also true. Okay, this relationship also exists in the perimeter. So for example, all right, PQ plus QR plus RS plus SP is similar by the same factor, okay, of similarity to AB plus BC plus CD plus DA. Okay, because perimeters are calculated by a factor of 1, they're not squared or anything like that. Okay, this allows us to be able to calculate perimeter using similarity. All right, so we're going to stop there and give you guys a chance to work on some problems, but think about how these are all related and how similar polygons also have a definition for their conditions like the congruent ones, and then we'll do some problems together the next time that we get together in class.